Hi and welcome to this brand new solution video of paper 12 of February-March 2024. If you like this effort of mine, please like by showing it a thumbs up, share this with your friends and subscribe to Math United. Let's get started with question number 1. Find the exact value of this definite integral. So let's rephrase this one like this. From 3 to infinity, but inside I will write 2x to the power minus 2 dx. Okay, because it's easier to integrate this way. So for integration we just add 1 to this and divide by the same addition to integrate this. So it will be 2 will remain 2, the power will go up by 1 and it will be divided by same addition and plus c from 3 to infinity. So what do we get? 2x to the power minus 1 divided by minus 1. So in place of dividing by minus 1 I'll just write minus here, so that's enough. 3 to infinity, and now I will substitute. I can write plus c also, substitute infinity and 3 here. So minus 2 infinity to the power minus 1 plus c minus 2 3 to the power minus 1 plus c. So first thing we should do, cancel c, it is part of the both. Now this one becomes minus 2 over infinity minus plus 2 over 3, and we can see that anything divided by a very large number is almost 0, so we can ignore this. Answer will be 2/3. Question number 2. The diagram shows part of the curve with equation y equal to k sine half x. This is the angle where k is the positive constant and x is measured in radians. So the curve has a minimum point at A. State the coordinates of A. Okay. For any minimum or maximum which are the stationary points, dy over dx has to be equal to 0. And that's what we'll do here. We will differentiate this first. So dy over dx in this case will be, k is a constant multiplying, so it will remain k. Sine half x, its differentiation will be half cos half x. Okay. So what do we get here? This has to be equal to 0. So half k cannot be equal to 0, right? It's a constant. So this is not our answer. This can be equal to 0. Cos half x equal to 0. So half x equal to cos inverse 0. Now cos inverse 0, we can see that the first stationary point is there and the second stationary point is A. So whenever we get such a solution, let's say what is cos 0? Cos graph looks like this. So first 0 comes at pi by 2, which will give us this point. So we will ignore this. Second point is 3 pi by 2, which will give this one. So we will write 3 pi by 2 only. So half x is equal to 3 pi by 2. Both sides are dividing by 2, so we can multiply by 2, cancelled. So x is equal to 3 pi. So the x coordinate of this one is 3 pi. State the coordinates of A, that means y is needed. For y, what will we do? We substitute this 3 pi into the equation. So y is equal to k sine half times 3 pi, which is 3 pi by 2 again. So y equal to k, and sine 3 pi by 2 is minus 1. So y is equal to minus k, and that makes sense. It is below x-axis, it's minus k. So the coordinates of a are 3 pi comma minus k. B part, the sequence of transformations is applied to the curve in the following order. Translation first. Normally we do stretch or reflection first, but it's translation first. So if they are asking us to do this, we'll do this first. Otherwise, this is not the right sequence. Find the equation of the new curve and determine the coordinates of the point on the new curve corresponding to A. Okay. So what was our equation? Our equation becomes y equal to k sine half x. Y equal to k sine half x. X was 3 pi at A. So this is our equation, right? We have to translate it by 2 units first. In the negative y direction, means down direction. So minus 2, it is translated down 2 units. Let's call it the transformed function. Then we have to reflect on x-axis. So this is x-axis, this is y-axis. When we reflect, the points down there become positive, and the ones which are positive y's become negative. That means the y changes. This is y, and this is also whole of it is y. That means if I want to reflect it, I can write it like this: minus k sine 3 pi by 2 minus 2 inside. Okay, and if I open the bracket, it is minus k sine 3 pi by 2. What is sine 3 pi by 2? Minus 1. And minus and minus plus 2. So this minus and this minus multiply, again it will become positive. So y is k plus 2. Okay, so y coordinate becomes this, and there is, when we reflect, there is no change in x coordinate. It remains where it is. If we translate up or down, again the x coordinate remains same. So the question was, determine the coordinates of the point on the new curve corresponding to A. So the new coordinate of, let's call it A prime, are, the x coordinate remains same, y coordinate becomes k plus 2. That's it. A curve is such that dy over dx is this. So it's not written properly, dy over dx. 3 4x plus 5 power half. It is given that the points 1 to 9 and 5a lie on the curve. Find the value of a. So to find the value of a, we should know the equation of the curve first. So what will we do? We will dy, we'll keep it here, and 3 4x plus 5 to the power half we'll write here, and dx will come and stay with the right side. So we'll integrate them now. So integration of dy will be y. Here it will be 3, and because it's a linear part inside, so it becomes easy. We will just add 1 to its exponent and divide by the same exponent. And further we have to divide by the differentiation of what is inside the bracket, and differentiation of 4x plus 5 is just 4, because differentiation of 5 is 0, so we'll divide just by 4. Alright, let's try to simplify this now. Y equal to 3 4x plus 5 to the power 3 over 2 over 3 over 2. 1 half plus 1 is 3 over 2. I'm not writing 3 over 2, I will multiply 2 here. Denominator of a denominator can become numerator, and then we have 4 here. 3 and 3 cancel, 2 and 4 also cancel, So y finally comes out to be 4x plus 5 to the power 3 over 2 over 2. And I did not write c here, I should have written the c. So now to find the value of c, we should substitute this point to get c. So substitute 1 9 1 9. Okay, in place of y I will write 9 equal to 4. In place of x I will write 1 plus 5 to the power 3 over 2 over 2 plus c. So what is 4 times 1? 4. 4 plus 5, 9. And 9 to the power 3 over 2 is 27. 27 over 2 plus c. So c becomes 9 minus 27 over 2, which is 18, minus 9 over 2, which is minus 4.5. Minus, let's give it 9 over 2. This is c. So our equation becomes, what was the equation? This was the equation. Equation becomes y equal to 4x plus 5 to the power 3 over 2 over 2 minus 9 over 2. Okay, this is what our equation is. Now we have to find a. So we'll substitute 5 in place of x and we'll get a. A will be replacing y. So a is equal to 4 times 5 plus 5 to the power 3 over 2 over 2 minus 9 over 2. So a equal to 20 plus 5, 25, 25, 3 over 2, 125 over 2 minus 9 over 2. So it's 116 over 2. So a is equal to 58. We got the value of a. Question number 4, a part. Prove this identity. So we can see a square here, so that makes our job easy. We'll just square this. So you may know the identity a plus b whole square is a square plus b square plus 2ab. That is the identity I'm going to use here while opening this. So it will become sine square theta, which is a square plus b square plus 2ab. After that we have minus 1 divided by cos square theta. This is our left hand side. So sine square plus cos square is 1. Yeah, that's an identity. And we have minus 1. So these can cancel. So what are we left with? 2 sine theta cos theta over cos square theta. This cos theta and 1 square cancel out. We are left with what? 2 sine theta over cos theta. And sine theta over cos theta is tan theta. So we get 2 tan theta, which is right hand side. So left hand side equal to right hand side. We have proven the identity. Hence, solve this equation. And if we can see that the left hand side of this is exactly left hand side of this. So in place of this, we can write 2 tan theta. That's what our starting point will be. So 2 tan theta equal to 5 tan cube theta. Right? Both of them have tan theta, so we cannot cancel it. Normally, if there are constants, we divide both sides by the same number, right? But here we won't do that. So what will I do? I'll keep 0 here and bring 2 tan theta to the other side. So 5 tan cube theta is already here. And 2 tan theta comes after this. So we can take tan theta common here. So it is 5 tan square theta left in this one because 1 is out, and out of this tan theta is already out, only 2 is left. Now two parts are multiplying and their multiplication is 0. In that case we equate them equal to 0 individually. So tan theta is equal to 0. So theta is equal to tan inverse 0. And theta is just 1 0. If you remember the graph of tan, let me show you here. Graph of tan looks like this. This is in radians or degrees. So this is 90, this is minus 90, and they are the asymptotes, and it goes like this. So there is only one place in tan's graph where theta is 0, right? Tan theta is 0. So this is the only answer we can have from here, from this. So I will erase this graph. It was just for help. I just wanted to see that you don't have to go and look for other answers, because this is the only answer between minus 90 and 90. Alright, second one, this one is 5 tan square theta minus 2 equal to 0. 5 tan square theta equal to 2. Tan square theta equal to 2 over 5. And now we will square root both sides to get rid of square from here. For that we have to put plus and minus here. So this is square and square cancel. So tan theta equal to plus and minus square root 2 over 5, 0.4 we can write here. Right? Now let's focus on the positive part first. Theta is equal to tan inverse square root 0.4. Please don't think that 0.4 is 0.2, okay? Square root of 0.4 is not 0.2. Some of you might be thinking that, okay? So if I put that in my calculator, I get theta equal to 32.3 degrees. Now the second one was tan theta equal to negative 0.4. So when is tan theta negative? From 90, sorry, positive 90 is here, negative 90 is here. So in this, where is tan negative? Tan is negative in this quadrant, right? That means this 32.3 will also be applicable because it is negative here. So 32.3 degrees. So visually I can see that the third answer is theta equal to minus 32.3 degrees, because we have to give answer from negative 90 to positive 90. So these are the three answers, 1, 2 and 3. Question number 5. A curve has an equation y equal to 3 over 2x square minus 5. Find the equation of the normal to the curve at point this, giving your answer in the form of this, where a, b, c are integers. So equation of a normal. Normal is a line, right? So equation of any line, in this case normal, is this: y minus y1 equal to m x minus x1, where x1, y1 are the coordinates of the point where the normal is there on the curve. So y minus y1 is 1 equal to m, we have to find out, x minus 2. Only thing left is the gradient m. So we can't find the gradient of normal straightforwardly, so first we have to find gradient of tangent. And gradient of tangent is nothing but the differentiation of the curve at that point. So let's differentiate this by a quotient rule. Well, it's a reciprocal kind of function, so we can use quotient rule on this. So 2x square minus 5 is squared first, then 2x square minus 5 is written normally, and the numerator is differentiated. The differentiation of 3 is 0. That means this whole thing is useless. Minus. Differentiate the denominator now, so differentiation will be 4x, yeah, because 2 will come and multiply with 2, 4x, and differentiation of minus 5 is 0. Multiplied by the numerator, which is 3. So it comes out to be minus 12x over 2x square minus 5 square. So now at x is equal to 2, because our differentiation is in terms of x only, so we will look at the x coordinate only of the point where this tangent is there. So it will be dy over dx will be equal to minus 12 times 2 over 2 square minus 5 and whole square. So this is minus 24 over 4 times 2, 8, minus 5, 3. So it is 9. 3 square is 9. So we can simplify this, 8 over 3. So now our gradient of tangent is minus 8 over 3. So gradient of normal is negative reciprocal of gradient of tangent. So it will be 3 over 8. Negative reciprocal of minus 8 over 3 will be 3 over 8 positive. That's what we'll write here. Since the format they want is this, so we'll cross multiply 8 with this. So it becomes 8y minus 8 equal to 3 multiplied with this, so 3x minus 6. Since x is first, so this has to be positive. That means I'll bring 8y and minus 8 to the right side. So 0 equal to 3x minus 6 minus 8y plus 8. And if I swap their places, it will be 3x minus 8y plus 2 equal to 0, which is the format they wanted. Question number 6. It is given that the coefficient of x cube in the expansion of this is 432. Find the value of a. Very straightforward question. So we can see that this is a binomial expansion candidate. That's what we should do. Okay. So but if I write it properly first, let me show you what is this. 2 plus ax to the power 4 times 5 minus ax. We have to find the value of this a, and the coefficient of x cube is 432. How can I get x cube? By multiplying with 5. From here I need x cube, so that 5 and that x cube give us x cube, right? So that means in the expansion of this, I'll just focus on where we have the power of ax as 3. So that will be my starting point. Ax to the power 3. So when we start with one of the terms in binomial with the power, we give it a coefficient of 4c, and the same number we gave exponent here, 4c3. Okay, 4 is the exponent, the maximum exponent we have. It will be multiplied by the second term with an exponent, so that the sum of the previous exponent and this exponent will be the maximum. So 3 plus 1 will give us 4. So it will be 1. This will give us x cube, and then we have to multiply it with 5 so that we get the x cube term. I hope you understand. So this is done. Now we have to see what will multiply with ax so that we get an x cube. Obviously, if ax is given a square, then it will become a cube ax cube, right? And same thing we'll do here. This time we'll write 4c2, because the exponent here is 2. And the second term is 2 here, which will get the remaining of the 4. So let's write that here. These are the only and only two terms. I didn't write minus. This was minus, right? I didn't write minus here. These are the only two terms which will give us a x cube. 2 from here and 2 from here. Okay, so let's simplify them. And their sum will be 432. That's what they've given, right? X cube. If I add these two, I will get 432 x cube. So I'm focusing only on x cube, not x4, not x square, nothing else. Okay. 4c3 is 4. Ax cube will be a cube x cube. 2 to the power 1 is 2 and 2 times 5 is 10. Plus 4c2 is 6. Square of ax will be a square x square. And this is minus ax, so I'll multiply with ax again, and let me get rid of this positive. I'll write negative here so that this negative sign is taken care of and I don't forget it. Okay, now 2 square is 4, and this is equal to 432 x cube. So this becomes 4 times 10, 40 a cube x cube minus 6 times 4, 24, and a square times a will be a cube, and x square times x will be x cube. Both of them are x cube now, and we don't need x cube actually. We can get rid of this by dividing all the terms by x cube so that they are gone. Gone, gone, and gone. 40 a cube minus 24 a cube is 16 a cube. 432. No x cube anymore. A cube will be equal to 432 divided by 16. And a cube is 432 divided by 16 is 20, 32, 11, 112, 7. And now we'll cube root both sides to get rid of cube. So a is equal to 3, and that's it. That's what they were asking us.